Okay, so let's start. My name is Iaroslav Ustinov. I'm solution architect in AWS. So today we are talking about different things that we announced on reInvent. It's our biggest event. It happens every year in Las Vegas in December usually. So my part is about AML. It's the most popular topic, I think, the second year in a row. So let's see what was announced, right? So actually, the first announcement I want to highlight is not directly related to AML, right? So in our, let's say, categories, it's more about the storage, but it's related. And can you raise your hand if you know what is RAC? Great. Super. So for you, it will be very interesting. For those who don't know, retrieval augmented generation is basically a framework that allows you to include the context from your private source of information, let's say internal Confluence or Wiki or whatever, into the model answers, right? And the way it works is that when you ask the model or the agent about something, in addition to the foundational data, which it was trained with, right? It can go to the vector database or vector storage, right? And get the information from there during the request, so that will be retrieval phase. Then it will check, so usually what it retrieves, it's not just one piece of information, it will be multiple parts of information, and it, depending how you are developing your agent, you even can kind of regulate how much information you want to retrieve on the first step. So then the model or the agent estimate what information is actually relevant to the query and augment it into the response, right? And then it generates the response with that augmented information. So in order the whole framework to work, you need vector storage, right? Because the way it works is that it's not like your information should be stored as a text, it should be stored as a vector. And the most, I think, popular storage, at least at the AWS platform, AWS is OpenSearch, for example, it supports vectors, or PostgreSQL, it has a pgvector. So now you can store vectors in S3, right? So it's not that we announced it on reInvent. In reInvent, it's actually became general available. It was in preview since summer, I think. Right? And the way it works is that in addition to the regular S3 API, there are additional calls that allows you to create this vector storage, put vectors into that, or search through it. That's kind of a little bit, like I said, right? So it's not directly AML related, but it's important for that. And the reason why you can use that, so if you need like super fast latency, of course, it's not an option. For that sense, in that sense, OpenSearch or Postgres will be faster. But when, for example, cost or scale is a primary factor, right? When you have like super big amount of information, or like you really, like cost for you is a very, very critical factor, then that's where S3 can shine. And also, if you're familiar, we have the actually managed RAC service called Knowledge Databases in Bedrock. So if you're using that, S3 also might be integrated as a vector storage there. Okay, so now about AI. So if we look into AWS AI portfolio as of today, there are, let's say, 3 layers, right? The bottom one is infrastructure. It includes compute itself, so obviously NVIDIA GPUs, right? And then GPUs developed for AWS and designed by AWS. It's Trainium and Inferentia, and actually in this reInvent, we introduced Ultra servers with Trainium 3, so it's third generation of these processors, and also Trainium 4 were announced. And as our CEO pointed that initially Trainium was developed for training the models, but actually, it appears that it's very effective in inference as well. So you can use it for both. Then also, we consider as part of infrastructure is Amazon SageMaker, which actually providing you all the tools for custom model building, if you need that, or data foundation for that AI. Again, if you are going to train your model or whatever. Then the middle layer, it's AI and agent development software. So the huge part of it is Amazon Bedrock. So basically, it includes multiple services. It includes foundational models. It includes different capabilities like guardrails, knowledge bases I just mentioned, and so on. And that's a new thing that, again, was announced like in between of reInvents, actually. In summer, it became generally available, I think, in September, October. It's called Agent Core. I will tell about it a little bit more, especially that some new announcement was related to that. And then it is a top layer. It's whether, let's say, ready applications or ready agents that you can just use. So on the left part, there are applications like Kiro. I don't know if who heard or used Kiro. Raise your hand. Yeah, so it's a spec-driven IDE, right? So then Quick Suite, Transform, I will tell about it a little bit. Or you can get, now we have Agentic Marketplace on AWS as well, so you can get third-party agents there. And also introduce something called Frontier Agents on this reInvent. It's like a totally new category, and I think one of the speakers today will tell about that, so not my topic, right? Okay, so back to the announcements. Let's start from the Bedrock. So the first one is that we brought, and actually Bedrock was the first platform who brought Mistral and Ministral models into it, right? For those who doesn't know, Mistral, I think, is the only LLM on the top layer developed in the European Union, in France specifically. Right, so it includes Mistral Large, it includes Mistral family, which is like mini models or smaller models. Right, all of them are available on the Bedrock, so you can use them with all the foundational models that was available before. Then the next announcement we made was about service tiers on the Bedrock. So basically now, when you are doing the inferencing with the Bedrock, you can choose one of these tiers, depending on what your focus is, right? So for example, priority one, it's the most expensive one, but actually requests for that tier are processed before all others, right? So again, if you need low latency, you're using that tier. So standard tier, as of the name, right, the standard one for the regular task, like average cost, average performance, right? So it's for regular, so before introducing of the service tiers, let's put it like that, everything was standard, right? Then Flex. So Flex is cost efficient for less urgent workloads, for example, for models evaluation or maybe for summarization where, like a couple of milliseconds doesn't matter actually. So everybody expect that if you're summarizing a big chunk of text, it will take some time and so on and so forth. And in this case, it will not be that fast. It's not low latency, but very cost efficient. And then for the big customers, reserved tiers is basically, you can compare it with the reservation of instances or whatever, like we have it for all other services. Basically, you can reserve compute capacity, or you can guarantee some input-output token per minute. So that's for that. Then, a year ago, on the last reInvent, we introduced, first time, our own foundational models. It's called Amazon Nova family, right? This year, we introduced the second generation of that model. So the first one is Nova Lite. So Nova Lite is, I would say, standard model with very good performance, with, I think, very good price-performance ratio. Right, so it's a reasoning model. It has different configurable budget levels, so it's like low level thinking, middle, and high level. So depending on your budget, right? So again, that's for daily tasks, or at least we are recommending to use it for that. Then the next one is Amazon Nova Pro. That's as of today, the most intelligent model that we have in Nova foundational models, right? So as the previous one, it has all these three thinking intensity levels. It's also multimodal. So multimodal. So it can get the input as an images, as a text, the audio, I think. So that one for like really deep researches, or maybe for like complex task of code generation, something like that, right? And again, here it's compared for the leader models back then in December, right? So it's compared with the Sonnet 4.5, it's compared with Gemini 2, because Gemini 3 wasn't released back then. And in these benchmarks, it actually was better than them in many criteria, right? So unfortunately, I don't have these benchmarks regarding the newer models. I guess we will have it, but that was as of December. Then the totally new model, so it's not the second generation, it's the first generation of this particular model. It's called Nova 2 Omni. That's the first in industry multimodality model where input and output are multimodal. So you can use, as an input, you can use text, image, video, audio. So now, if you try to build this kind of modality, you would know that you need to actually maintain different models. Like if a user is speaking, we are using that model. If user is writing or like getting or sending the image, we're using that model. For video input, we have the third model. Then we need to somehow combine all of that and then produce the input, right? Here, it's one model where you can use 4 types of inputs and 2 types of outputs. So it can produce the text, and also it can generate images, right? So from the reasoning perspective, it's very, very similar to, it has the same capabilities as Nova 2 Pro. And also important to mention that all 3 models and the next one actually have context window is 1 million tokens, right? So pretty much big context. Now, the next one is second generation of Sonic. So Sonic is an interesting one. It's a voice-to-voice model. It's usually used for, some voice assistance, or it's also, by the way, integrated with telephony providers like Twilio, like Connect we have. And even the first generation, I used it before, was very impressive. So, for example, to one of my customers, I showed the demo, and he didn't believe that it's like real-time demo, because the answers from that model was very, very fast, like without the pause. So you stop talking, like maybe a couple of milliseconds, and then start answering because of the streaming capabilities, right? So now it's even better. It also has additional languages like Portuguese and Hindu. Unfortunately, not Slovak yet. So there are English, German, Italian, French, Portuguese, Hindi, and Spanish, right? But maybe we will at some point. And the last one, I think, it's Amazon Nova Multimodal Embedding. So embedding model is something that you remember I told you about RAG, right? About how it works and about that we need a vector storage for that. So in order to actually transfer text into the vectors and extract that vectors, you need that embedding model, right? So there are multiple embedding models in the market. Before this announcement, we have Amazon Titan for that. But Amazon Nova also first multimodal embedding model. So you see, again, it can retrieve video, audio, visual documents, image, and text, and it's all one embedding model, right? So back then, again, it was the first model that was able to do that. Also, we introduced a very new service that's called Amazon Nova Forge. So imagine that you want to have your own LLM, which is, let's say, very, very industry specific. That industry has so much unpublic context, I don't know, maybe plane construction or something like that, that RAG will not be an option, right? So with RAG, you will not be that accurate because of the amount of information that you need to actually embed into the model. So for that, you might say, well, okay, maybe I will train my own model for that. And I include all that context into the model, and it will be fast, I don't need that RAG. And so the one option you have is basically training from scratch. But if you read, the news, how much money OpenAI or Anthropic or whoever spending on training of that models, you might imagine that, maybe it's a little bit expensive. So Amazon Forge actually allows you to train that models, but not from scratch. You can start the training from the specific checkpoints of our Nova models, right? And also what you can do, you don't have to generate the whole training set. You can use our curated training set and embed your information into it for training that models. So it simplifies the training of your own models a lot. And it's a very cost-effective way to do that. And also, obviously, it's integrated with SageMaker AI, which was designed for training your own models, as I told you before. Also, one interesting thing called Amazon Nova Act finally also became generally available. It was in a preview, even a research preview, I think, like not public available for a very, very long time. But basically, it's a tool that allows you to build in agents that are interacting with UI, let's say with the browser. For example, it's very, very useful tool for QAs who need to click something. So you can using the mix, for example, of Python and natural language, design that scenarios like what you want to test, and it can go in through AI, doing specific scenarios. It can also call some tools or APIs, and it's very good for aggressive testing. It's very good for programming different scenarios where UI is involved, right? So you can use it as of today. Now we are going to the Agent Core, which I mentioned before. So what is Agent Core? So Agent Core is a platform where you are going to build, deploy, and operate agents at scale. So whoever tried to build his own agent? Not so many people. But for those who tried knows that modern frameworks like, I don't know, LangChain or Pydantic AI or ours, Strengths, they are becoming, with help of them, it's becoming simpler and simpler to build the agents. So the build, let's say, prototype or MVP is not that hard, these days at least, right? It has all the capabilities, it's integratable with different things. But after you build it, this proof of concept, and want to actually deploy it in scale, operate it in scale, that's where it might be challenging. And that's actually what Agent Core was designed for, right? So Agent Core itself, it consists of several components. The first component is called Agent Core Runtime. So basically what you can do, you can get your agent, and it doesn't matter what kind of framework you were using for developing it. You can deploy it into that runtime as a container, right? So it will be automatically containerized. So you can think of it as if you're familiar with it, as a ECS Fargate for agents, where you are not, dealing with infrastructure, you are dealing with the, agent, basically instances that are deployed, and they will be scaled if that's needed. Right. The next component is a memory. So if you're talking with ChatGPT or an Anthropic Claude, you know that it's maintaining the memory, and actually two types of memory. Short-term memory is the memory of that current session you're talking, right? So it remembers within that session what you're talking about. And then there is a long-term memory that when it remembers something about you or about it maintaining something across all conversations that you had. And when you come back with a new conversation, this short-term memory will be clear, it will be completely new, but the long-term memory, he will remember that, this guy is working in IT, he's 35 or whatever, so I know something about them, I remember something about it. So that memory should be stored somewhere, that memory should be retrieved somehow, right? So in Agent Core, there is a specific component which is responsible for that, and obviously it's integrated with runtime. The next component called Gateway. So here you can think of it as a API gateway, but for the agent, right? So who is familiar with MCP protocol? Okay, that's a very popular thing these days. So MCP protocol or model context protocol, you can think of it as an API for the agent, right? So Gateway allows you to maintain multiple MCPs behind it, So it's kind of a level of abstraction for the agent, right? So agent doesn't know about any MCPs that you are using. It knows about the gateway. And this gateway allows, for example, do a query like, what kind of tools do I have today? And the agent can request these tools, go through it, okay, these tools, this tool I need to use for this specific request, and go use it. And also, you can use not only MCP behind that gateway, but actually like the old-fashioned API as you want. It doesn't matter for the agent because all it's interacting with is the gateway itself. So what you put behind it, it doesn't matter. And by the way, runtime also might be used for hosting MCP servers, not only agents. Then we have, I would say, specific tools as a components of this agent core. The first one is browser. So whenever agents need to interact with the browser for, kind of simulate the user experience, go through it, you can use that. It will be maintained like in a secure container. And in order to actually interact with this browser, you need some kind of framework. And Nova Act, which I mentioned before, might be one of that framework to interact with the browser. And the second one is code interpreter. So that one is for the situation when imagine that you ask your agent, to calculate something relatively complex. So LLMs are not very good at that. And what they're doing, they can generate a code, let's say JavaScript or Python code, to calculate what you want and then provide you an answer. But in order to do so, they need to have an access to some kind of environment to do so, right? So again, if you are talking, for example, with Anthropic Claude, like in a web interface, so it can do that, it can generate you the code, but it's not the part of foundational model, right? It's a part of the agent that you are talking with. So code interpreter does exactly that. So it allows the agent to basically quickly span the secure environment, let's say with Python inside, generate some code, run it inside it, get the answer, and then kill this environment because it doesn't need it anymore. Right? And again, it's all like integrated with the runtime, or if you're using, for example, Strengths as a framework, then in Strengths you can interact with all these components. It's like it's within the framework. Then it is an identity. Identity is basically allows you, first of all, we call it inbound identity when your application or model or agent should be identified against the agent itself, right? Or if agent should be identified against the gateway, right? And basically define, does actually agent has access to this type of tools or not, depending on his identity, right? So identity allows you to do both of this type of authentication. And then it is observability. Obviously, it's like, one kind of, it's a centralized tool. It's based on CloudWatch, which allows you to observe like the whole stack or the whole agent core platform. And also what's important here is that you're not obligated to use all of that components. You can use some of them. You can use one of them if you want. For example, I have a customer who built its own runtime long before we actually announced runtime, right? He doesn't need runtime. But he was interested very much in memory, he was interested very much in gateway, and he's using it, right? Or you can use only runtime and nothing else for some reasons, right? So it's not that they are very, very tightly connected. It's better together, right? They're designed for that, but you can use each of them independently. So that was Agent Core before reInvent, right? On reInvent, we also announced 2 new capabilities. The first one called policies. So it's, I would say, complementary to identification. It allows you to generate the policy, what agent can and can't do, whether in a specific language called Cedar, it's on the right, or even in natural language. You can basically describe what you want your agent be allowed to do, or not allowed to do. And then your natural language will be transferred into the Cedar. And also, within this capability of policy, it is like internal evaluation. So basically, this tool can say, it's actually what you want, it's not very secure. Maybe you reconsider, or I will recommend you to make it that way. So that's not generally available yet. It's a public preview, so it has some restrictions, but still you can use it. And the second tool, also in public preview, called evaluations. And evaluations, actually, it's a very hot topic among the customers or among the people who is already building things, right? Or who is already have agents in production. And the problem now they're having is that imagine that you have an agent that's a little bit more complex than just, question answer. Imagine it's some multi-step process, or it's like multi-agent collaboration, something like that, or your generation interfaces in input out of that, right? And then when you're writing that agent, you actually were using something like Anthropic Claude 3.5 or Anthropic Claude 3.7, which are now in the end of life, right? So you need to replace them because Anthropic is not going to support them. But your question is like, yeah, these new models, they are supposed to be better, but for my specific prompts, for my specific workflow, I'm not sure of that they will perform as it is better, right? Or maybe Gemini 3 was announced and you realize that actually it's better than the model I'm currently using. So how to evaluate that, the output of your agentic application will be on the same level. So that's the task that evaluation designed to solve, right? So it can evaluate using LLM as a judge approach. It can evaluate through the pre-designed scenarios. There are some, you can estimate this response quality in terms of correctness, in terms of helpfulness, you see, right? Or something totally custom. You can program it like your business logic or your criteria if you want it. So again, it's in preview, not generally available yet, but announced. So now that's how Agent Core platform looks like after the reInvent, right? And I think we are going to, expand this since agentic applications becomes more and more popular. Okay, and now we are coming to to three announcements on the infrastructure level, like to the SageMaker AI. So first of all, we introduced MLflow serverless capability. Who knows what MLflow is? Yeah, okay, that's where we have hardcore guys. So basically, it's an open source platform for managing the model lifecycle, right? And before that, it's a very popular one. And even though SageMaker AI itself has, some of the capabilities that the platform has, that's kind of very popular platform among the data scientists. And before that, you actually could use that inside SageMaker AI, but for that, you need to spin up EC2, you need to manage that, you need to upgrade the MLflow version if you need it. With serverless, as usual, is everything with serverless, and I think you will hear in the presentation about serverless, you need to manage that. Like now you are focusing on using MLflow rather than operating it, right? Then the next announcement was training plans for the SageMaker AI inference. So as you can imagine, if you are not familiar with the training plans, right, even from the name, initially it was about the training. And the purpose of that was that, unfortunately we have only one NVIDIA on the planet. And that means that the number of GPU is limited, right? And everybody nowadays wants GPU. So training plan was a mechanism how to reserve that GPUs for training specifically for a specific dates and duration, right? Now you can do that for inference as well. If you are inferencing not using serverless Bedrock, but you're inferencing, but you deployed your inference into the SageMaker AI. And the third one is now SageMaker AI supports bidirectional streaming. So what does it mean? Imagine that you are developing something voice to text, right? And so bidirectional streaming, it's something that allows you, when you're starting speaking, like actually it doesn't wait until you stop speaking and then send your voice to the model. It started sending you voice like from the very beginning, and it's getting it as a stream. And the same about the answer. So when models started answering you, you are seeing like you're not waiting until it type it all and then send it to you. You are seeing it again as a stream. So, for example, Novasonic, I told you before, this voice-to-voice model, it actually works in that state only, in this bidirectional streaming. But now, if you're developing something custom on SageMaker AI, you can use it as well. Okay, and then there is a service that's called AWS Transform. So that was, if you remember that diagram of stack I've showed you, that's on the very top, right? So basically, AWS Transform is an agent or agentic AI service which allows you to do different transformations. Initially, it was designed for 3 use cases. VMware migration, mainframe modernization, very popular in financial industry, and then full stack Windows modernization, which means if you want, for example, migrate from your .NET for Windows to this, cross operational system like .NET for Linux. I forgot the name. I'm not .NET person, sorry for that. Or you want to migrate Microsoft SQL with a lot of stored procedures and stuff into the Postgres, right? So basically, it provides you the plan of such a migration. It can execute some parts of the plan, not everything, and so on and so forth. It's very convenient. And on reInvent, we announced something called AWS Transform Custom. So the initial idea, I think, that's my speculation, that they wanted to introduce more use cases, but then they realized it's better maybe to do it something more or less universal and let people decide what they want to migrate, actually. So it has some out-of-the-box cases. For example, now it includes Java environment migration, if you want to migrate from Java 8 to the more modern versions, or Python environment migrations. But also, if you have like completely custom case, let's say maybe you want to migrate your code from C++ to Rust, right? Very popular these days, by the way. So you can do that with AWS Transform Custom as well. So for this type of migration, very, very useful tool. And that's it. Thank you very much. Any questions? Any questions?
For the last thing about migration, how do you ensure that the migration from Python to Rust actually is the same thing? Do you have to? How do you make sure that you transport the code to different languages?
So it's So first of all, it doesn't work like a pure code generating thing, right? So it's a agentic application which is designed to first of all provide you the plan, right? So basically, it gets okay to migrate like from this to that. You need to do 1, 2, 3, 4, 5, and then you can chat with him that actually that's not that, like you're wrong, right? So for the cases out of the box, of course, it's pre-trained. Like he knows that, for example, in Java you use Maven, and you need to modify your Maven, and it provides a plan for that as well. So it's not as with let's say AI IDE these days, where I want the web application, and then you're waiting for 1 hour, and then it generates something, right? So it's not like that. So it's step by step because it's initially designed for enterprises, like for the really big migration where. Because if it's small migration, it doesn't make sense to use a tool like that. You can do it manually, or you can do it like using some basic AI tool. That tool is like, actually, AWS Transform is one of the showcases. We use it inside Amazon to migrate, I don't remember exactly how many million of strings of code of very old Java, right, to the more modern one. So I think it's one of the cases where we used it like very massively in Amazon. Yeah.
I want to ask about the policies, because as I know about the AI ecosystem and topics and stuff, that sometimes when you say to AI agent that you cannot use something, then he discovers, well, I can use Python. So they somehow go around the rule, so they don't break the rule, but they like do the stuff anyway. So my question is like, how good are these policies?
So I think there are two kind of sides of my answer, right? The first one is this natural language capability for policies. It's just the feature, but in the end, it transforms it into the setter language. So it will be, definitive rule. It's not based on it's based on the natural language, but in the end, it will be. You might think of it as a JSON, so it's not natural language. It might be interpreted only by one, deterministically, right? That's the first thing. And the second thing, these policies are about interaction agents with the surroundings, right? For example, what access to what tools in the gateway it has.
Yeah,
so it's
that was exactly the point. They forbid some tool, but it discovered it can run Python scripts and access.
Yeah, but since, for example, if it interacts with the gateway, you saw like it was this arrows, which like these policies and authentications, they are integrating with the runtime and with the gateway, right? So since it's a part of the whole, let's say, agentic platform, so they are maintaining not only inside the agent, not only inside the runtime, but inside gateway as well. So if agent doesn't allow to use the specific tools, gateway will not allow him to do that. And it doesn't matter what kind of tool he's trying to use for that, right? He's going through the gateway if you program him to go through the gateway.
So the rules are about using tools, not about doing some specific.
Well, there are, yeah, so if you don't want him to do some, I don't know, like if it's about bad words or bad topics, that's actually, we do have something called guardrails on the Bedrock, but it's...
Publishing private GitHub.
Say again?
Or publishing private GitHub, you know. It's, the standard attacks.
Yeah, but for that again, so that's more about access of agent or runtime in this case, right? Because it's deployed in the runtime into the specific, tools you have. It's the same as if you give access to USC2 and run some code on it, it will do the same. Like it's not that. So whether your agent or EC2 has access to something or hasn't, right?
But I heard about instances when the AI agent was able to leverage the access. So it doesn't have the, for example, root access, but somehow gets to the root access. Like use some hacky shady stuff. So my question is like, do we have some information how secure this is, or like we need to wait for hackers to try how to do it?
But I mean, it's not the magic, right? So if your agent deployed at something that has some specific permissions, I don't think it can go around that, right? So especially if you are operating, let's say, inside one ecosystem, which is Agent Core, or even AWS, where we have all this, in the end, it's all IAM, right, inside AWS. Okay?
I think I might have a question about this transform.
Okay.
So I wonder how does it work? So does it need a direct access to source code or binaries? Or it just replicates your environment?
No, obviously, it should look into your code for that matter. Obviously, yes. Otherwise, what the plan it will provide to you? Like some generic plan, usually, to migrate from Java 8 to Java 21, we are doing 1, 2, 3. That doesn't make sense.
Mentioning VMware support, and for
Yeah.
instance, I now have a situation that we have a fleet of VMware hosts that runs a very strange thing called Progress Open Edge that comes customized Tomcat with the stuff with some libraries, and I wonder if you could somehow automatically containerize it or give any kind of converted infrastructure on AWS. But it's not even, it's a kind of Frankenstein from Java, whatever else, and plus something customized internally.
So I think it's more like offline conversation about that specific scenarios, right? So how it works, how it operates in them. I just don't have information about that, unfortunately. Yeah, definitely. And I think our AWS Transform team will be happy to hear about that. So, okay, thank you very much.